Diagram 10 show a semicircle ABCD. Okay, we have a semicircle over here ABCD with center D. The point P move in such a way that PB is equal to BC and equal to BA. So BC, BA, same length. The locus curve of point P is a circle with center B. We want to find, for the first part, we want to find the distance of BC. So we use this formula, distance between 2 points, x squared minus x1, not x squared, x2 minus x1 square, plus y2 minus y1 square, and then square root the whole thing. Now I'm going to use this formula to help me get the distance between B and C. Nine minus 2 square plus 4 minus 3 square, and then square root the whole thing. So 9 minus 2 is equal to 7, 7 square, 49. 4 minus 3 equal to 1, 1 square you will still get 1. Okay, so the answer is square root of 50. The distance of BC is square root of 50 units. Now let's try part B. We want to show that the equation of the locus of point P is equal to this. Okay, the question tell you that the point P moves such that its distance from B always equal to the distance between BC and BA, which is equal to square root of 50. Right? This is what we got just now. Now, how do we find the distance between PB using still using the same formula, right? So x minus 2, or maybe let me write this one first. PB is equal to square root of 50. Okay, so PB is equal to BC and equal to BA, which is equal to square root of 50. Now, how do we get PB? X minus 2 square plus y minus 3 square root the whole thing. This will be the distance of PB and equal to this. Now what do we need to do? We square both sides so that we can get rid of the square root sign, and then we can rearrange all the terms. X minus 2 square plus y minus 3 square is equal to 50. Now we can do expansion here. X square minus 4x plus 4 plus y square minus 6y plus 9 is equal to 50. Okay, let us rearrange all the terms nicely. X square plus y square minus 4x minus 6y plus 13 is equal to 50. X square plus y square minus 4x minus 6y plus 13 minus 50 is equal to 0. Okay, one more step to go. This is equal to 37. Okay, is this correct? X squared plus y squared minus 4x minus 6y minus 37 is equal to 0. Okay, correct. Now, let's try the last part. Find the area of the major sector BAPC. Okay, major sector BAPC will be here. We are looking for the area of this major sector. Okay, so you have two formula. First formula you learn in monomath, which is pi r squared times theta over 360, right? This one is the area of the formula for finding the area of a sector. This angle is in degree. If you don't want to use this, we have another formula which we learn in circular measure chapter. 1 over 2 r squared theta. If you are using this formula, the data needs to be in radian. If you are using this formula, the data need to be in degree. So I will show you both. You will notice that both give you exactly the same answer. Okay, now first is to determine the data here. What is the data here? Try to think, what is this angle? ABC, 90 degree. Okay, so remember the angle at the circumference subtended by the diameter of the circle always equal to 90 degree. Now let's say I have a circle over here. This is a diameter. This is the diameter of the circle. Angle at the circumference subtended by the diameter. This one you learn in Form 3 or 90 degree. Okay, so now we know this is 90 degree. If this is 90 degree, here will be 270 degree, right? 360 minus 90 degree. Okay, now since I want to show you both, let me convert this angle in degree to radian first. Degree to radian. How do we convert degree to radian? We have to time pi over 180, right? Radian to degree backward time 180 divided by pi. Okay, so 270 degree is actually equal to 270 times pi over 180, and then this will be in radian, which is equal to 3 over 2 pi. 3 over 2 pi radian. Okay, let's use this formula first, and later on I will show you how do we use this formula, and you will notice that both formulae give you exactly the same answer. Pi r square. Okay, the r is over here, which is the distance of BC. Pi r square time theta in degree over 360. Okay, so square root of 50, you square, you will get 50. So you just key in your calculator 50 times 270 over 360. Okay, 37.5 pi square unit. How about this one? One over 2 r square theta. Theta need to be in radian, which is 3 over 2 pi. 3 over 2 pi. Okay, still getting the same answer, which is 37.5 pi square unit. Let's try part 2. Hence, we want to show that the area of the shade region, this one, is equal to this. Okay, just now we got the area of sector, which include these two parts, right? Now we need to find a way to help us to find the area of this segment. These two segments having the same area. So you will notice that ABC is actually an isosceles triangle because the distance here and here are the same. And this is the center of the semicircle, right? So if you draw a line from here, go down here, this will be 90 degree. Okay, now how do we find the area of a segment? Still remember the formula: 1 over 2 r squared theta minus 1 over 2 r squared sine theta. 1 over 2 r squared theta is the area of sector. 1 over 2 r squared sine theta is the area of triangle. So you take the area of sector minus the area of this triangle, then you will be able to get the area of the segment. Okay, if you are using this, as I told just now, must be in radian. This one, it can be in radian or degree. If this is in radian, when you key in your calculator, you need to be more careful. Now let me show you. Let's say I want to key in sine 90 degree. I just need to make sure your calculator here is showing a small d. It means that in the degree mode. So you press sine 90. You don't have to press anything. Your calculator know that this is in degree. So you get 1. But okay, 90 degree is equal to pi over 2 radian, right? But let's say now if you want to press radian, sine pi over 2, you press like this, your calculator will assume that this is in degree. You press equal, you will not able to get 1. So you need to tell your calculator that this is in radian. So press option first, angle unit, and choose number 2. Now you have a small r appear here, then your calculator know this is actually in radian. So you press equal, you get exactly the same answer as sine 90 degree. Okay, let's find the area of this segment first. Area of segment 1 over 2 r squared. Oh, we need to find the radius of this semicircle first. The radius of this semicircle is not BC but BD. So we need the distance between point B and point D first. So BD is equal to, still using the formula that we used just now, x2 minus x1 square plus y2 minus y1 square, then square root the whole thing. 6 minus 2 square plus 0 minus 3 square root. This is 4 square 16, and this is negative 3, you square it, you get 9, square root of 25, which is equal to 5. Now we know that the radius of the semicircle is actually 5. So area of segment is equal to 1 over 2 r squared. Data need to be in radian. Pi over 2. 90 degree, right? Okay. Then minus 1 over 2 r squared. One over 2 r squared sine theta. So let me just use degree easier. This one you can just press your calculator. This should be 5 squared, you get 25 over 2. Over 2 times 2 is equal to 4. Okay. And how about this one? This is 25 over 2. 25 over 2 sine 90 degree is equal to 1. Okay, let me check, is this correct? Okay, this is the area of one segment. Now, we want to show that the area of the shaded region, area of the shaded region is equal to this, right? So how do we find the area of the shaded region? We use the area of the sector that we got just now, which is equal to 37.5 pi, right? Let me check. Okay, yes. The answer for C1, 37.5 pi. The area of the major sector, BAPC, minus 2 times this. 2 times this one. Why do we need to times 2? Because we have 2 segments over here and they're having the same area. Two times 25 over 4, you will get 12.5. 12.5 pi. Negative become positive, and you will get 25. Okay. 37.5 pi minus 12.5 pi is equal to 25 pi. Is that correct? Let me check. Yeah, 25 pi. Then plus 25. And we can just factorize the 25 out. You will get 25 times pi plus 1 unit, square unit. Is that correct? Yes. Sure.